So you're telling me we can turn these spools of plastic through this machine and make cool, pretty stuff at home for less than $200? That's pretty insane. The concept of 3D printing is actually not very new. It was popularized around 2010 as something you could do at home, low cost, but the idea of it goes back to the 1940s and the very first implementation, the 1970s. So it actually predates regular printers, oddly enough. The machine itself is actually fairly simple, so we'll take a look at what goes into it to make pretty little products like these at home. Let's start by getting familiar with the printer itself and the basic principles behind it. We'll find out how we can turn this spool of plastic material into a planet. At its core, the 3D printer is really just a robot. And what's allowed people to be able to do this at home is the price reduction and ease of semiconductors being put into products. So the processor in this printer is actually as powerful as a Pentium 2. So the computer people were using, the latest and greatest back in the mid-90s, is actually slower than what is processing this print right now, just for reference. The printer consists of 4 separate types of motors. They look like this. Pretty simple, right? Well, we've got one for the x-axis to tell it back and forth. We've got one for the y-axis to go front and back. Then we've got one, although I have 2 for stability, on the z-axis going up and down. So take it back to math class with x, y, and z, because it's 3D. And then finally, there is an extruder. So it takes our plastic spools, which come in many colors and many types of plastic. This one even has wood additive in it. It melts them down in a chamber here, which is electrified with a heating element, and pushes it out of this nozzle. That is the extruder. The extruder motor feeds that plastic spool into the hot part, which then deposits it on the print bed. But without the processor knowing exactly how, when, and where to deliver that melty plastic goo, we wouldn't be able to do this at home cheaply or easily. So, when I say exactly, I really mean it. This thing is working in 1/100th of millimeters. Just to emphasize how small that is, this dime comes out at 17.9 millimeters. Attempting to roughly measure the year on the dime puts us at 1.1 millimeters, and that's not even very accurate. Just to further emphasize, that's 1/10 of a millimeter there. You can't even see daylight between the calipers, can you? We're working with 1/100th of millimeters. Once you've got your plastic ready to go, you're going to preheat it, just like an oven, for the different kinds of filaments you can use. So in this case, we're going to be using PLA, which is actually biodegradable in its natural form. And this is going to become preheated while we go to the computer and look for what we're going to print. Using special software called a slicer, we give the printer a very specific set of instructions where to be, when, and how long to be there. We take a 3D image and run it through this slicing software, and it puts it out in different layers, so the printer can build it one layer at a time. This image of Pluto is 296 layers, and it will take approximately 3 hours to finish printing. Because this model of Pluto is a globe shape, we'll need supports to go around it to hold it up, because we can't print on thin air. The software generates this for us, and then we save it to an SD card. Alright, we've got the SD card in there, we've got it preheated, so now we're going to hit print. Choose our file, Pluto, and it's going to begin making sure that the bed is completely flat, because it needs a perfectly flat surface to work with. So, as we can see, it did its leveling. It took this probe on this side that's lit up and touched 25 points on the bed to figure out what the distance was between the print nozzle and the bed. You need to get it absolutely perfect or it will fail every single time. Yeah. There's also sensors on the x-axis and the y-axis to tell where the bed is at that way. But that is how the printer knows where it is while it's depositing the goo very specifically. So we're on layer 1. There are 296 layers of Pluto here, and it will take approximately 3 hours to do, which is on the shorter end. So, sadly, after all of that, 3 hours later, it didn't work. And the reason it didn't work is because at the very top of the print, it needed to slow down instead of continuing to go the same speed. Sometimes the software builds in an adaptation for that. Other times it's just simply not enough to compensate for it, since it's a very thin object at the top going from very thick, and it's fairly lightweight. It's easy for it to push around. So unfortunately, we'll have to try it again.